Hello, and in this video, we're going to start section 1.5, which is about solving quadratic equations. So first, a quadratic equation in X is an equation that can be written in the standard form ax squared plus bx plus c equals 0. So what you want to notice here is that your highest degree is a 2. So your power is a 2, or of course, this is a square. Now, obviously these values can be rearranged, but when we say standard form, you do have one side equal to 0. And that's actually important in some of our solving techniques, which we'll see below. We also call it a second degree polynomial equation because your highest degree here, or your highest power in this case, is 2. Now, quadratic equations can have either 0, 1, or 2 real solutions. However, we're also going to include imaginary numbers here using those complex number systems. And then in that case, they will have either 1 or 2 solutions, which may or may not be real or imaginary. If solutions are real, this is also a nice little tip here. These are also the x-intercepts of the graph. So any real solutions to our equations we can see on a graph as x-intercepts. If the solutions are not real, so if they're imaginary, you're not going to be able to see them on the graph. Obviously, you'll see that there are no x-intercepts instead. But again, it's just a nice also visual check to your answers. So we'll look at that a little bit too. Now, there are 4 ways that we can solve quadratic equations. So I'm going to show you each of the 4 methods here, and we'll do a couple examples of each type. So the first way that you can solve a quadratic equation is by factoring. So this is strategy number 1. It uses what's called the zero product principle, or you may have heard it as zero product property. And basically it says that if A times B is 0, then either A is 0 or B is 0, or I suppose both of them could be 0. So if you multiply 2 things together and the answer is 0, one of the original factors has to be 0. There's no other way to get a 0 answer when we multiply unless something is 0 to start with. And we use this idea when we solve by factoring. Now, there are 4 strategies that we're going to go through, and some are better in certain situations. So this technique is really helpful, obviously, when a quadratic is easily factored. Not all quadratics are factorable, right? We've seen before, or hopefully you've seen before, that some polynomials are prime, meaning they can't be factored. So not every quadratic is going to be factorable, particularly in the real world. When we get to real world applications, it's very, very rare that something is factorable. But for the more basic questions, if you can easily factor something, then this is usually a nice strategy to use because it's relatively quick. So what you're going to do first is you do want to make sure that you are in standard form, meaning that one side of the equation is equal to 0. You're going to factor completely, and then you're going to set each factor equal to 0, which is really us applying that zero product principle, and we're going to solve the equations. And then, of course, you can always check your solutions in the original equation. So let's start factoring. Now, here I'm going to start by taking the GCFO, which is our greatest common factor, and I notice that they each have a 2 in common and an x. So I'm going to divide those out. 4 divided by 2 is 2, and if I have an x squared and I remove one x, I still have an x left over. Now, in the next group, you do need a placeholder there. So you may be saying, well, you took the whole 2x out, but there's always a factor of 1, right? Because 2 divided by 2 is 1. So if I have nothing, I can write that 1 in. I know we don't often write the 1 in, but if I have nothing there, I do need something, so I can put that 1. So now this is completely factored. I can't break either of these down any further. So what you do is you set each factor equal to 0 and solve. So now we just have a regular problem. I divide this first one by 2 and I get x equals 0. Here I'm going to add 1 first. I get 2x equals 1. Divide this by 2 and I have my solution x equals 1/2. So in this case, I have 2 solutions here, 2 real number solutions, excuse me, that complete this equation. Now you can check it by plugging your values back in. So I'll just do one check here, but I don't want to spend too much time doing all the checks. So you can always check all of your equations by plugging that value back in. So if I check x equals 0, and I replace my x's with 0 here, we can see that this checks out very quickly, right? This becomes 0, this becomes 0. So 0 minus 0 is 0. And if I check the 1/2, I would have 4 times 1/2 squared minus 2 times 1/2. Well, 1/2 squared is going to be 1/2 times 1/2, which is 1/4. And you're going to notice that our fractions here are going to cancel, right? I'm left with just a 1 and a 1, and 1 minus 1 is 0. So both of these solutions check out. And I'll let you check the rest of the examples on your own if you want to verify that your answers are actually valid. Okay, let's do another one. Now remember, your first step is you have to be equal 0. So the first thing you want to do is bring that 4 over to the other side. So I'm going to subtract it on both sides. And I'm going to start with 2x squared plus 7x minus 4 equals 0. You do want to be careful. So a lot of times students may start factoring and try to set each of the factors equal to 4 instead. That is incorrect. This technique only works if you're equal to 0. So you want to be really careful. Sometimes they'll give you harder problems where maybe it looks like it's already factored, or you think you're ready to start because it's equal a number, but you can't start factoring until everything is nice and simplified and you have a nice standard form equation. So if you have a harder problem where not everything is on one side or there's already parentheses there, you probably still need to clear everything out first and reorganize. So to use the factoring technique, you really need to be in this nice clean form here. Now I'm going to factor this one. If I look, I don't have a GCF that comes out, so I'm just going to have to use one of my techniques for trinomials. And I like trial and error, so I'm just going to factor my first part here, and then I'm going to factor my second part. So I need a -4, so I could either do -1 times 4, or 1 times -4, or -2 times 2. And what you're trying to do here is to find the right combination so that if you multiply it back out, you get this 7 in the middle. Okay, so it looks like that's the one that works. And I'm going to check it. So just make sure that you're 100% positive in your factorization before you move on. So you can always check by multiplying 2x squared plus 8x minus 1x minus 4. 8 minus 1 is positive 7. So we are good to start. That is the correct factorization. I'm going to set each factor equal to 0 here. And I'm going to go ahead and solve. And again, I have 2 solutions. And you can go back and check these on your own. You're going to plug them into the original equation there and check that way. Okay. All right. So the other thing I want to do here is I do want to show you how to check using a graph as well. It's a good check, although the best check is to actually plug them back in, right? Because graphs are a little bit more visual. Sometimes they're a little harder to see exactly where you have x-intercepts. But I do want to show you that. So let me stop sharing for 1 second. And what I'm going to do on my graph is I'm going to just type in these 2 equations right into the graph so that we can actually see them, okay? And what I'm going to do there as well is I'm going to type them in the standard form. That's usually the best way to do it, and dropping the 0. So what you're going to do is set y equals 4x squared minus 2x to check by graphing. And then over here, I'm going to use y equals 2x squared plus 7x minus 4, again, to check by graphing. And then in those cases, remember, your real solutions will be the x-intercepts. So we should see these values as our x-intercepts on that graph. Okay, so if you're checking by graphing, again, make sure you're in that standard form first and just use that one side of the equation to plug into Desmos. So I'm going to go ahead and do that. All right, let me stop sharing. Let me bring Desmos up and I'll share that with you guys. So I'm going to type in the first example. So have your sheet out in front of you so you can follow along. I'm going to use y equals 4x squared minus 2x. So again, I'm using just the left side of that equation in standard form. And what I'm seeing here is I'm going to notice that my x-intercepts where I cross the x-axis are at x is 0 and at x equals a half. And those were our two answers. So remember, we're just looking at the x values here, not the y part. But we can see our first example, A, was 0 and 1/2. And those are both there. If I do the other example, okay, so there we are in blue on the other example. You'll see that we have our two x-intercepts. So one of them is at -4, and the other one is also at 1/2. And those were our answers as well to our equations. So this is a good way to check your work, particularly if you have real solutions and the answers are pretty clear. If your answers are a little bit harder to see, then, I mean, you're just kind of maybe looking for an approximation, but not a perfect check, but at least you can see if you're in the ballpark by looking at that graph. But again, you really want to be in that standard form to check by graphing and just use the left side of the equation. Okay, so let's go back to our other handout. Okay. So that's solving by factoring. And again, this is a really nice technique if you're good at factoring, obviously, and if the quadratic is easily factorable. If you're spending a lot of time trying to think about factoring and you're not getting anywhere, then we're probably going to use a different strategy. Now, one last side note, if you need that review on factoring, don't forget, you can go to my YouTube channel and look at the MAT162 course and look at section P5. So if you need that factoring review, it's a pretty thorough review there because it's something that we spend a lot of time on in that class. You're more than welcome to watch those videos if you need help to learn how to factor. I focus on trial and error here, but there is also a way to do trinomials by grouping. So again, if you need that extra help, go check out those videos or just check out section P5 in your text. Right. The second strategy that we can use is called the square root property. So the square root property says that if you have a square equals something, then what you can do is take the square root of both sides and get the answer that way. So I'm just going to do a very basic example so you can see. Like if I have x squared equals 4, something like that, well, to solve it, you take the square root of both sides. But with square roots, when you're solving, you take positive and negative versions. So your root and your square cancel on the left, and you're left with plus and minus root 4. Well, in this case, the square root of 4 is 2, so you get two answers. I get positive 2, and I get negative 2. And that's what that square root property says. Now, this technique is not going to work for every single example off the bat, but it is really helpful when you have a squared expression that is isolated by itself on one side of the equation. So you don't need to be in standard form here. You actually want to have a square part. And the big thing is you're going to notice that all your variables are part of a square. So in our last example, notice that here, I have an x that's not part of a square, right? It's not being squared. And here I have an x that's also not being squared. So these are not examples that I would want to use the square root property on. They're not going to work. In our examples below, though, notice that in the first example, the only x I have is squared. In the second example, the only x I have is squared. And even in this last example, my x is in a square. So this is a nice technique if your variable is squared and you don't have any extra x's hanging around. So to solve this, you're going to isolate the square part of the problem if it's not already done. So get it by itself. Then you're going to apply the square root property and take the positive and negative square root of each side. And you're going to continue to solve for x and simplify as needed. So first step is to get the square by itself. So I'm going to start by moving the 15 to the other side. I'm going to divide by 3. And I have x squared equals 5. Now the square is totally by itself. So what I'm going to do is take that square root of both sides. And don't forget, it's always plus and minus. So x is equal to positive and negative square root of 5. Now, that is fine. You can leave it like that. If you want an approximation, you could use a calculator to get a decimal answer, but usually we like to leave it as the root answer unless it says for you to round. So I'm going to leave that. So this plus or minus just means that there are 2 answers. If you don't like that, you can always write them separately. Square root of 5 and x equals negative square root of 5. And of course, you can still do that same check. I forgot to add it in the steps here. Guess we'll just add it in below. You can always check your answer. And we'd go back to the original and plug in that each of those roots and make sure they check out. So root 5 squared, that's just going to cancel. So it's just 3 times 5 minus 15, which is 0. And of course, this is true. And you can also check the negative as well. I'll just do that mentally. So if I plug in negative root 5, well, a negative squared also becomes a positive. So you're still going to end up with 5 here and also check out. The next example is very similar. So I'm going to start by isolating that square. And again, I like this method, particularly when I have all my variables as part of a square. Otherwise, it's not a good method to use. Okay. So x squared equals negative 25 over 9. I'm going to go ahead and take the square root of both sides there. And plus or minus. So I have x is equal to positive and negative square root of negative 25 over 9. Now we do want to simplify that. I have a negative, so I have an imaginary number here, which is fine. So this is actually plus or minus the square root of negative 1 times the square root of 25 over the square root of 9. When we have multiplication and division, we can break it down with roots, but not with adding or subtracting. And if I clean this up, well, this is I, root 25 is 5, and root 9 is 3. So we have plus or minus I times 5/3. Or 5/3 I. You could write it the other way as well. So again, you have 2 answers here. One's positive and one is negative. And they are both imaginary in this case. So if we check with the graph here, you're going to notice that it's, I'm going to do this one for you now. I'll change to the other screen, that we're not going to have any any x-intercept, excuse me. All right, so let's see. I'm going to do new share. Go back here. So if I plug in that one, and again, I'm just using, it's in standard form already. So I'm just using the 9x squared plus 25. Oh, I'm going to zoom out a bit here so we can see the graph. And you can see there that there are no x-intercepts. So you still have solutions, but they're imaginary. So on the graph, we're not going to see them as x-intercepts. Whereas in the first example I did, again, it's already in standard form, so I'm just typing in that left side. 3x squared minus 15, you do see that you have 2 intercepts there. And remember, it was root 5, so you're not going to get nice answers, but you can check and make sure it seems correct. So I could always use my calculator to get root 5 and see if these approximate root 5, and they will. All right, and let's do the last one. Now, this one may look a little bit different, but notice that it's still in that same form. My variable is being squared and there's no extra x's around. Also notice that my square part is already isolated here. So if I had something else with it, like let's say I did a different problem, it was like x minus 5 squared plus 2 equals 4. Well, you still have to isolate the square. I still have to bring the 2 over. And I would do that before I start. Okay, so you're still isolating the square piece here. This one's already done. So if it's already isolated, you're going to take that square root of both sides, plus or minus. And what happens is this whole thing cancels, and you're left with x minus 2 equals positive and negative root 6. Now here I have a little bit more to do because x isn't by itself. So you do want to add that 2 to both sides. And what I get is x is equal to 2 plus or minus root 6. Now this is two answers. X equals 2 plus root 6 and x equals 2 minus root 6. And I'm not going to bring up the graph again here, but these are both real numbers. I know they look kind of messy, but they are real numbers. So you would see two x-intercepts on your graph. Okay. So if I type in 2 plus the square root of 6, you get the number about 4.449. It's a real number. It just looks a little bit messy. So usually we leave it in the root form unless the question says otherwise.